My name is Joerg Forstner, and I'd like to talk about data warehousing at my company, partitions.com. So I want to give you some overview of the techniques that we use in our data warehouse. And what am I going to talk about? First of all, I will give you some introduction. So why we use a data warehouse at partitions.com. Give you an overview of the data warehouse, of the infrastructure, the process from start to the end. Then I will present you staging with BIML, how we use BIML to extract data from the source to staging, and I will present you some techniques how to process cubes. First of all, some information about me. I'm SQL data warehouse developer at partitions.com. Partitions.com is a company which provides online betting, online playing games. And my education is that I studied technical mathematics at the University in Linz and switched into software development. So I studied mathematics and then I started to work in the IT. And during my work, I was able to make some certifications like the SQL query certification or some project management certifications and also bookkeeper tests. I'm IT guy since 2006, and I started as an application engineer, software engineer, and I switched to BI consulting. Oops. And I also could gather some experience concerning data science. So about my company, Partitions, just a short introduction. It was founded by Franz and Joerg about 20 years ago, so next year we have our 20-year anniversary. And the company is situated in Linz. And the holding in Germany is part of the French BetClick group. And we develop just for our own purposes in Linz, so development is completely in Linz. And so we have no external customers in that sense, it's just for our purposes. And the company operates in Malta, Austria, Gibraltar, and Germany. So here you can see a short overview about our company structure. We have the holding in Germany, the IT in Austria, in Linz, and then some holdings in Malta. So we offer online bets and online gaming. So we have some products like sport bets, bets on virtual sports, games, casino games, poker, and esports. And we have about 5 million customers in the meantime and about 300 employees. So why do we use a data warehouse? We have a huge amount of data because I think you can imagine that we have 5 million customers and small percentage plays regularly, daily, hourly. And so we have a lot of bets, we have a lot of transactions, money transactions. And so a huge amount of data is collected. So for example, we have 25,000 different bets for over 75 kinds of sports and a lot of games. And we have to provide daily reports for our customers. Our customers are the controlling guys or the bookkeepers. And so they require every day the current balance and current value and the current revenue, and they have to report it every day to our mother company. And of course we use data warehouse not only for report purposes, also for data analysis purposes and data science purposes. So how do we work, how do we act, how do we build our data warehouse? So we have a main database where all the data gets inserted and updated and deleted because of the gambling actions. And so there's a real big movement in this database. So we use a replication of this database, and this is our base for our data warehouse. So we extract all our data from this replication. So how do we set up the data warehouse? So we have this replication as a source. We extract from this source and try to extract all the data into a staging database. So we just simply take more or less a one-to-one copy of the source tables and just stage it. At the same time, we audit. So we just try to gather information about the extraction process and maybe some metadata and everything we need to see to find errors, to log, to just to see what's going on in every step. So when we have, first of all, the staging database, then of course we have a dimensional database because we have to perform some clearing, some transformations to provide the data in the form we need for the cube. So we have a dimensional database with tables by transforming actions, and then we use this data in this dimensional database and provide this data in a cube. So our customers, our controllers, most of the time they use Excel. So this is the tool of their choice, and so they just connect to the cube via Excel and just build the reports with Excel. So which technologies do we use? So we try to use a lot of the Microsoft BI stack. So in our particular case, we have the integration services, SSIS, and SSIS used with project deployment, because there's package deployment and project deployment. We decided to use project deployment. So we have some environments, so we can set up environments and use project parameters. So we can perform the ETL part, extraction and transform and load everything with integration services. So we also use BIML, the BI markup language, when we perform staging. So this, I will go deep into this later on. This is a great tool, in my opinion, to optimize and to make it simple to create packages, SSIS packages. Also, we use, of course, a lot of TSQL. We use a lot of stored procedures or SQL commands for transforming, for extracting, and for building the cube. And building the cube, we use the analysis services, SSAS.
May I ask a question for the replication? What kind of tool do you use? Do you use the built-in transactional replication, or?
Yes.
Okay.
He helps me. So, what's the process? The whole data warehouse process. So we perform delta loads on a regular basis. So every day we perform delta load. So we just extract data from, not the last day, but on a regular specific period. And only full load when necessary. So we just do it maybe once a year, twice a year, or if some requirements have to be implemented which require full load. But normally we have just daily delta loads. We of course audit the information. So we want to find out are there errors or are there some steps dubious along the whole process. And what we use when we extract deltas is we use the raw version of database. So a lot of data warehouses I know just have dates. They use just delta for date sake, extract from yesterday, data from yesterday, and from now to yesterday, and we take a raw version. The row version is nothing more or nothing else than a timestamp, but this timestamp is database wide. So this is a counter for the whole database. So we extract data when we perform a delta load just from the last successfully extracted row version up to the row version when we start the extraction. So to show this in the picture again, to summarize, we extract from the source from the replication and extract this data to the staging database. We use the BI markup language to do so. Then we transform and load the data into the dimensional database, and then we process the cube. When we process the cube, we try to perform processing partition-wise, so not the whole cube, just partitions of the cube. So we use, as I told before, BI markup language to extract data. And why do we use the BI markup language? All the packages to extract data from the source look the same, more or less. So it's just audit some metadata, maybe count some rows before the extraction in the table, then extract, write it to the destination table, and then count again the rows you have extracted, audit some metadata. And this is just the same structure for every table. So we can use BI markup language to avoid a lot of programming by hand. The BI markup language is reusable, time-saving, flexible, and not so error-prone, of course. So the next step is the transformation. When we have the data loaded into the staging database, we have to transform data. And this is, of course, transformed according to our business rules. And we use the approach by BIML. So we have this approach to use a star scheme. So we have dimensional fact tables, and we try to connect the facts and the dimensions via a star scheme. And we provide data for the cube using views. And when we process the cubes, we use the process analysis service process task in the integration services to process the cube. And what we do is, because we do partition-wise processing, we just mark the partitions we really have to process because of the new data we loaded. And so we have during the delta load just a partition-wise strategy to process. I will talk about this later on. So we try to avoid a full process of the cube as much as possible. Of course, when we do full load means full processing, but delta load should be fast. So this is just the overview of the database, and the first part I would like to show is how we do staging with the BI markup language. So the BI markup language, or BIML is the abbreviation for the BI markup language, and is a dialect of XML. And it provides agile, SSIS, and SSAS developing, so you can use also BI markup language for analysis services. But we, in our case in Flattertown, we just use it for integration services. So you can define SSIS packages and other BI objects with the help of the BI markup language. So we use the tool BIML Express. This is a plugin of Visual Studio. So we develop BIML code inside Visual Studio, and we use BIML Express to create the packages and to check maybe errors. When you have a look at the BI markup language file, you will see that it's also possible to embed C# code or Visual Basic code. You can perform some coding. You can include other BIML files. And you can even include namespaces of the .NET framework. So I will show you later an example how to do that. When you have BIML Express in your Visual Studio, you can check with a simple click, right-click, mouse-click. What you can do with BIML files, you can add a new BIML file to your solution, of course, and you can generate SSAS packages. So when you have a BIML file, you can simply say, okay, generate the packages, and all the SSAS packages are generated. And you can check the BIML file for errors. So, as I said before, we use packages which have the same structure. So at the beginning of the package, we audit some metadata, and we count the rows before the population. It should be 0 because you truncate the staging tables at the beginning. If you don't, you see in the audit table, of course, okay, I missed to truncate the tables, and you see a count row greater than 0. Okay, but normally it should be 0 because you truncate the staging tables. Then you populate the tables, and then at the end of the package, you count the rows after the population to see, okay, how many rows did I really extract, and maybe audit the counts. So I'd like to show you how such a BIML file looks like. So here you can see, for example, the basic structure of a BIML file that we use in our company. You can see you've got some standard tag here. So this is just provided automatically, but you can see here it looks like XML. It's a dialect of XML. And we use project deployment, so you define in this section, projects, which packages you use. So you just define the packages which belong to your project, and you define environment variables if you have some. And then you can see a section called packages. So each package, we use some variables, and we use a data flow task to extract it and write it to the destination table. And you can define this in those ways. You have inside the section packages, you say, okay, use the section variables to define the variables, use the task section to define the tasks you have in the package. And of course, you can define the data flow. You can also define some connections if you have some special connections in the package. Otherwise, if you have some global connections, you can define them later on as in the own section connections. So more in detail, this is just the template, how you can build a simple BIML file to create packages which just look, as I told, audit, count before extraction, then load, extract and load, and then count and audit again. So what we do is when we have to provide some statements when we extract data from the source. And it's just more or less something like select those and those columns from table X, Y, Z, and maybe some where condition. But it's always the same type of statement. So it's a good idea, at least it's the idea that we follow, that we have a table And inside this table, we just have the definition of the package name, the SQL statement we use to extract, and the where condition and the columns we'd like to extract. And then you can use inside the BIML file some C# code, just loop over the table, and then build the BIML file dynamically with that code. So you can also define a BIML file if you want only for the audit, and you can also define a BIML file if you want just for the count, because it's always the same. Count is a simple select count from statement, or audit is always the same. It's just a procedure that says insert something into an audit table. So for example, what you can do is something like this. So this is the template expanded for our purposes. So what we do is we have a table, and inside this table we just define for every package the name and the SQL statement to how to extract the data, some where conditions, the columns we like to extract, because we do not need all columns of the source. And what we do is just, we have here some C# code, and this C# code just fills data from this table where we store the metadata inside this data table object. If you have a look just above, you can see you can also include some classes, C# classes. You can include those namespaces from C# from .NET framework if you like. You can define the language you want to use. And just to go on, how to use the template for the purposes we want. We have the project section again, and in this project section we define the packages we use in the project. So what we do is, in this section packages, we just loop over the tables where we define the packages and just perform the package creation, just to define which packages have to be used to the project. And each package is created the following way. So you have here the packages section, start of the packages section, that we loop again over this table where we define the packages. And then we say, okay, the package should have the name according to the source code here. And then you can loop over this metadata over this table with the packages, and then you can see we have here this SQL statement to extract data. So we use something like select those columns you want defined in the metadata table from the source table, where's something, where condition. Then you can call BIML script, which makes the auditing. This is in this section. You can make a task for count before extraction. Then you can make this data flow, which extracts data from the source and writes into the destination. And then you can also call a BIML script again to audit and count the rows after the extraction. So, are there any questions? So this is one way how you can use BIML just to perform simple package creation. And you can see here the advantages of BIML, because you can just code, and this code is not so error prone. Just if the code works, it works for the packages. You just create the packages according to this code and everything is fine.
I have a question. Do I understand that correct, that the sense of this is creating packages and you use your local .NET framework installed on your development machine to generate those packages? Okay.
So you can just simply, as we use Visual Studio 2013, for example, we have this BIML Express installed for Visual Studio 2013, and we use code, C# code, this simple C# code, just generate with this BIML Express menu, and the packages are generated just according to this code.
Not just two different languages you can use. C# or
Visual Basic, yes.
Just the two.
Maybe it's possible. I'm not sure. Maybe F#
Okay.
could be possible too. I only work with C#, but sometimes Visual Basic, I must admit. Any other questions so far? Okay. Just some remark, because I told you that we use some audit of counts before and after the extraction, and the count star statement, select count star from something, might be very slow for large tables. So you can also use a statement like this. You can select from a sys table, and this is much faster. Just as a hint.
Unless you need some predicate.
Pardon?
Unless you need some predicate.
Yes.
Is it reliable? So is it updated in real time, or is there some delay for the partition status view?
I didn't really analyze that, but we don't have the problem since we use the replication, and so we have, let's say, something static. But at the moment we just make the extraction. The tables are up to date. That's this views, and so we can perform this kind of statement for the count. Well, this was staging part.
So your source system is also SQL Server, or?
Yes. So everything
You
is.
can use it, but when it is a different database, you can use those stats.
Yeah.
And
Yeah.
maybe
So, yeah.
the counting lasts a long time.
Yes. But we use SQL Server, Microsoft SQL Server. We have no other technology.
So tables are partitioned on both sides, like on a source and a destination?
The tables themselves are not partitioned. So this is just a view which counts, which has a row count as a column. It just tracks the count inside the column. So but the tables themselves don't have partitions. No. So the next part of the database I'd like to show you is how to process the cube. So we have extracted the data and we have performed some transformation on the data, and then we want to provide this data in the cube. So we have to process the cube and move the data into this cube. So what we do is dynamic processing. So we don't process the whole cube when we perform delta load. We try to perform processing only on partitions that we need. So first of all, we partition measure groups. Measure groups in the with respect to the timeline. So we have some yearly partitions, we have some monthly partitions, we have some daily partitions, but it's defined by a time range. And you can partition measure groups only with enterprise version of the analysis services. When you process a cube, and you have a default partition. It's just a big partition where all the data for the measure group is located. And you can define partitions and process those partitions. You have to take care when you perform partitioning that the partitions do not overlap, because then you have double data inside the cube. So if you have overlapping partitions, you have data which is in the intersection of those partitions twice. So what are the advantages of partitioning of a cube? Of course, you have to process less of the cube. You only process partitions which are in concern because of new or changed data. The queries on the cube only act on the needed partitions, which means that you have normally less I/O, and the memory consumption can also be reduced because partitions can be processed in parallel. So when you want to consume a cube, you have to provide that the cube is in a processed state. And so there are several ways how to process a cube. So there's some possibilities. One way to process is to make a full process, which means that the data is completely removed from the cube, and then loaded again from the dimensional database. And afterwards, all indexes and aggregations are performed as well. When you perform a full process, it's pretty straightforward in the SSIS processing task, because you just only define the objects, the dimensions you want to process, and the measures you want to process, and say just make a full process and that's it. But that's not good practice, let's say it this way, because we do partition-wise processing, and we can use inside this SSIS process task an expression. So we can provide an XMLA expression which makes partition-wise processing. So we can define the partitions we want to process in an XMLA file and say, okay, just process this partition. So the fundamentals and the ideas of how to process dynamically and how to process partitions was introduced by Benjamin Austin, and his idea was just to use this dynamic approach using this expression XMLA with inside the expression of the task. So we can have a look at the template, how this XMLA looks like. So you can see XMLA file looks like this. You define the database where the cube is situated, the identifier of the cube, the identifier of the measure group you want to process, and then you have here in this section object definition a section called partition, and there you define which partition you want to process and the name of the partition. And then you have made the data source and the partition query. So this query is the important part. This query defines the data which is located and processed inside this partition. So this partition query section provides, here you define the query you need to select the data you want to have in the partition. In the section regular, you can use, or you should use, this type in processing mode, just have the partitions available for the user after data is loaded and the aggregations are performed. So the dynamic part, so this is just, you can do this also with a static partition. You can define a partition, say, okay, let's make a partition for 2018, a partition for 2017, data for 2016, and sometime back, for example. You could do this processing, this processing task and this XMLA just for static partitions. So when do you have to process a partition? When new data has to be processed into this partition, or maybe some data has just changed, or if the time boundary has changed. So you have partitions, fixed partitions, static partitions for each year, but maybe you get data for 2019, for example, for some reason. So then you have to define another partition for year 2019 and then process the cube. So this static partitioning has the disadvantage that you have to track somehow the data, but keep in mind, okay, what's the data I've loaded, and just perform or create a partition for new data if it doesn't fit into an existing partition. So the partitions, when you create partitions, there's the idea to create those partitions dynamically. So this means that the boundaries, the time boundaries, have to be loaded with queries, and the partitions may not overlap, and static queries just result in permanent work to adapt those partitions. So you need some dynamic strategy to create partitions and to process the partitions without fixed time ranges. Yeah, this is just